Now we are going to start with the preparations of phenol. So there are so many methods by which we can prepare phenol, but out of them these are the important one. That is the hydrolysis of Dizonium salt. Hydrolysis, again I missed it, hydrolysis again of sodium benzene sulfonate. From chlorobenzene we can prepare it, and we can also prepare it by the oxidation of cumin. So first we will start with an important hydrolysis of the Dizonium salt. So that is hydrolysis of Dizonium salt. So first of all we need to prepare the Dizonium salt. So what is Dizonium salt actually? For this what you need to take is, we need to take an aniline. What is aniline? Any benzene ring which has the NH2 group attached to it is called as aniline. Now we are going to react it with NaNO2 and HCl. That means we need to react with the combination of NaNO2 and HCl. What as a result we'll see? We'll see a Dizonium salt, and particularly the salt will be Dizonium chloride. This will be Dizonium salt called as Dizonium chloride. Now how we can prepare? Now this is our Dizonium chloride. Now we need to hydrolyze it. Hydrolyze it means we need to add water. That means water is going to hydrolyze it, and this occur particularly in presence of any acid. So what happens when you react in the same way? This OH group comes here, H reacts with Cl, and we get N2 as gas. So this is our phenol. So this is how you can prepare by the hydrolysis of the Dizonium salt. Right, I think it's clear. Aniline with combination, NaNO2 with HCl, we add them, we get Dizonium chloride. Then hydrolysis, we add water, it occurs in presence of acid, and particularly we get OH with HCl and N2. Now second we are going to prepare from the hydrolysis of sodium benzene sulfonate. So first let's see that what is sodium benzene sulfonate. Sodium benzene sulfonate is that any benzene ring which has SO3 Na group is called as benzene sulfonate. So first, like if we want to prepare, we need to convert it into sodium phenoxide, and how we'll do it? We'll just hydrolyze it. So when we hydrolyze it, we get ONA group attached to the benzene, and what is that? Sodium phenoxide. This is sodium phenoxide. Then we need to add acid to it. Let's say HCl. Then what happened? H comes here, forms phenol, and NaCl is liberated. So this is how you can prepare from hydrolysis of sodium benzene sulfonate. See, when you carried out hydrolysis, it turns into a phenoxide. Then you add an acid, and when you add an acid, what happens? It forms in phenol, and NaCl is liberated. Third, we can prepare from chlorobenzene. You know that what is chlorobenzene? Chlorobenzene is particularly benzene ring with chlorine attached directly. This is our chlorobenzene. Right. Again we need to convert into sodium phenoxide, and how we'll do? By reacting with NaOH. So when you react with NaOH, you get sodium phenoxide. And once you get sodium phenoxide, you know how to do it. You just need to, and you know that when you add NaOH with Cl, you need to heat it in presence of copper. Then only sodium phenoxide is formed. Then once the sodium phenoxide is formed, as we did in this case, we need to react with an acid, and we get phenol, and NaCl is liberated. And this is particularly being given a special name, that is dose process. Right. Next we have is oxidation of cumin. That means we can have it from cumin. So let's see first what is cumin, or how we prepare cumin. You need to take a benzene ring, and you need to react with propene. This is propene. So when you just react them, heat them together, you get a compound this will get attached here from the site of the double bond. This is 1, 2, 3, this bond becomes single. This is cumin. This is cumin. Now what you do it, you oxidize it. Oxidize means you need to add oxygen, and this becomes 3 also, because you need to satisfy the valency of carbon along with that. So what happened, it turns out to be like this, CH3. In order to make it easy, do one thing, write it here, because you need to oxidize, you can put the oxygen directly here. So it will be CH3, C, OOH, and this remain as such. When you oxidize, these O comes in between C and H, it turns out to be carboxylic acid. Then you add again an acid, hydrolysis again with the help of an acid, and what you get phenol, and along with that, you know that it gets break like this, and along with that you get a ketone, and particularly this is acetone, that is propanone. Right. So this is how you can prepare. So first take benzene ring, add, I'll write here, this is benzene ring, you add propene to it, and as a result you get cumin. Then to cumin you oxidize, and as a result you get an intermediate like this, followed by hydrolysis, you get phenol, and with acetone is formed. So these are the 4 important methods, that is Dizonium salt, hydrolysis of sodium benzene, sulfonate from chlorobenzene, and oxidation of cumin, that you can get the phenol actually, and you have seen actually that how we get it. Now coming on to the physical properties, that how these phenols look like. So if we talk about the state, they are actually you know that they are colorless, can be solid also, can be liquid also, but once you expose them to air they turn reddish. The reason being they get oxidized. So when you when they are oxidized they turn reddish. So otherwise if you talk about the original color, the phenol are colorless. Second, odor, as they are you know that member of alcohol, so that means they will be having a strong phenolic odor. They will be having a strong phenolic odor. Third is the solubility. Like you must be thinking that they have an OH group, so that means they will be highly soluble in water, but you know that they are only sparingly soluble. They are only sparingly soluble. The reason behind that, because though they contain the OH group which can be into hydrogen bonding, but still it contains such a bulky group, and this bulky aryl group is actually non-polar. So they are sparingly soluble due to presence of bulky aryl group, which makes it only soluble, best soluble in the organic solvents, but not in the the water. Now next is the boiling point. You know that they have higher boiling points than alcohol. They have actually higher boiling points than alcohol. The reason being, like if you see alcohol, phenol, like this is our phenol, we know that. So what happened? It gets into an association with the another phenol molecule. It get into an association with another phenol molecule. So somehow you can say that its mass increases. So as you can see that they are into a like they do a hydrogen bonding with the other phenol molecules, giving rise to an associated kind of structure, and due to this association, as you can see that hydrogen bondings, due to this association they comparatively have higher molecular mass, and therefore their boiling point is higher as compared to the alcohols. So this is how you are going to comment on their physical properties, that is state they are colorless, solid or liquid, but turn reddish when get oxidized. Odor, phenolic odor. Solubility, they are sparingly soluble because they contain a bulky aryl group in them. Boiling points, they have a higher boiling point, like if we compare a phenol and like we compare with the same mass alcohol, so phenol is going to possess the higher the boiling point. The reason being that it actually its molecule get into association with the another phenol, forming a hydrogen bond. So that means they get associated, and due to association their mass is somehow more, and we know that whenever the association occurs the boiling point also rises. So that means they are comparatively having a high boiling point as compared to the same member of the alcohol with same molecular mass, right. So these are the physical properties.